one more example video here. So this time we are evaluating inverse sine of tangent of 7 pi over 4. So what's different in these problems is that you have different trig functions. You have inverse sine of a different trig function. And the way to approach these is to work it in steps. So we would first want to figure out, all right, what is tangent of 7 pi over 4? And so to do that, we would want to locate 7 pi over 4 on the unit circle, so that's here. So here's our corresponding coordinates for x and y. Tangent is equal to y over x. So tangent of 7 pi over 4 is equal to the y coordinate, which is square root of 2 over 2, over the x coordinate, which is positive square root of 2 over 2. Now, you might notice, so these are kind of the same thing on the top and bottom, just opposite sign. So those are going to cancel, and you'll end up with negative 1 over 1, so just negative 1 here. For anybody who wants to see more steps to that, one thing you could do is bring this out of the denominator and flip it over, so 2 over the square root of 2. And then the 2's cancel, the square root of 2's cancel, and you're just left with negative 1 over 1. Okay, so this right here is equal to negative 1. Then we now want to find inverse sine of negative 1. So now the question is, what is the input into the sine function? Sine of what angle equals negative 1? And we have to remember to stick with the right side of the unit circle, because this is the range for inverse sine, negative pi over 2 to positive pi over 2. Sine, which is the y coordinate, has a value of negative 1 down here. The answer is not 3 pi over 2, though, because that's not between negative pi over 2 and positive pi over 2. Down here in quadrant 2, we don't use 5 pi over 3, we use negative pi over 3. We use the negative angles. This would be negative pi over 4, and so on. So the answer here for inverse sine of negative 1, the angle that we plug into the sine function to get an output of negative 1, is negative 1. That's the answer that lies in the range of inverse sine, which is negative pi over 2 to pi over 2. Okay, so here's another one. Inverse cosine of sine of 2 pi over 3. Same idea here. Let me erase a little bit, though, because we're doing inverse cosine this time. That's got a different range. The range for inverse cosine is 0 to pi, so we're looking here. Okay, but I did maybe get a little ahead of myself. We want to first figure out, I've lost track of my cursor. Okay, sine of 2 pi over 3. So 2 pi over 3, keep losing the little pointer, is right here. Sine is given by the y coordinate, so that's square root of 3 over 2. So this right here equals square root of 3 over 2. And we now want to find inverse cosine of square root of 3 over 2. So now we're asking ourselves, what's the angle that I plug into the cosine function that lies in this range from 0 to pi, where cosine of blank is equal to square root of 3 over 2. Cosine is given by the x-coordinate, so the x-coordinate square root of 3 over 2 here at pi over 6. And so our final answer on this one is pi over 6 radians. And that's the overall idea here, if you have different trig functions, is to do the inside first, find the value of, say, sine of 2 pi over 3, get that value, and then apply your outside function, in this case the inverse trig function.